Hello, this is video 14 for College Algebra, and this video covers quadratic graphs. We're going to be looking at standard form and vertex form of quadratics. So first of all, here's our standard form of a quadratic, ax squared plus bx plus c. Alright, and remember, if that a is greater than 0, the graph is going to open up, kind of like a smiley face. If a is less than 0, it's going to open down like a frowny face. All right. The x-intercepts are when the function f of x equals 0. So plug in 0 for f of x and solve for x. Your y-intercept will be your c value. So with our standard form, that's really easy to find, which is pretty cool. Finding our axis of symmetry, we use this equation x equals negative b over 2a. So if my b is already negative, we'll take the negative times that to make it positive. So some people say opposite b over 2a. And finding our vertex, we just take that x value from our axis of symmetry for our x value of our vertex, and we plug that in to find our y value of our vertex. Okay, and then another thing, remember, if the parabola opens up, it has a minimum. If it opens down, it has a maximum. So here's our quick little picture, just kind of showing these key features of a quadratic. We have our vertex, okay, and our axis of symmetry is a dotted line that goes through that. And then we have our two zeros, and then we also have our y-intercept. All right, and so that's just like what our base parabolas will look like. So let's look at an example. If I have x squared minus 6x plus 5, let's find the things that we automatically know. We automatically know our y-intercept is 5. That's our c value. Okay, the other things will be a little bit more difficult to find. So looking at our vertex, we're going to take negative b, so a negative 6 over 2 times 1, because that's my a value. So that means my x value of my vertex is 3. And then to find my y value, I plug in my 3 into my equation. And after I do that, 3 squared minus 6 times 3 plus 5, I do some math, get negative 4. Okay, finding our x-intercepts, that's where our graph crosses the x-axis. An easy way to do that is to factor or to look at your graph. So if I were to factor this, I would get x minus 1 and x minus 5. And so I know that my two zeros are going to be 1 and 5. Okay, and that can get us our two zeros. And they might be called x-intercepts. Sometimes you might see them as roots, zeros, solutions. All of those are appropriate for an x-intercept. And then our axis of symmetry, it's a vertical line, so it's x equals, and it's the x value of our vertex, so x equals 3. Okay, we can also do this by looking at our graph on our graphing calculator. If I type in x squared minus 6x plus 5 and I look at my graph, okay, I can either look at the table and find my intercepts, or just by looking at the graph, okay? And so we'll just kind of estimate here. There are my intercepts. My vertex is at 3, 5, or 3, negative 4, and my y-intercept is at 5. And on my graph, I'm going by 1 square is 2. And you can actually make a another point on your graph, a fifth point, because remember parabolas are symmetrical. So you could also put another point over here at 5. Okay, and if you want to draw on that axis of symmetry, that's that dashed line that goes through the middle of our quadratic. All right, looking at vertex form. Okay, it's a little different. Vertex form also, it can look like this after you complete the square. So after you complete a square, it will be in that vertex form. Same rules apply. If our a is bigger than 0, it opens up, it has a minimum. If a is less than 0, it opens down and has a maximum. X-intercepts, where f of x equals 0. Y-intercepts located at 0, comma, f of 0. So we're plugging in 0 for x. I'm sorry, yeah, 0 for x. Our axis of symmetry here, we don't have to find that. It's just going to be whatever this h value is. And our vertex is hk. So, doing an example, this equation, or this function, opens down because of that negative. Okay, the x-intercept, we will need to find that by setting our equation equal to 0. So, with this, we would subtract our 2, and then we can just kind of solve this. So we'd have the plus or minus square root of 2 equals x plus 5, and then we would subtract that. So we'd have negative 5 plus or minus the square root of 2. Now, some of us that makes total sense, some of us that doesn't make a lot of sense for us. So what we can look at is, if I actually type that in, negative 5 plus the square root of 2, I have a 0 at negative 3.58. And then if we found our other 0, it'd be at negative 6.4. Okay, so this is our exact answer with that square root, and here our approximate answers would be negative 3.6 and negative 6.4. That's what x would approximately equal. So on our x-intercepts, I'm just going to go ahead and write our exact, but it also means these points. So when we're graphing it, we'll be able to know what that actually means. All right, again, finding our y-intercept, we'd plug in 0 for 5. I'm sorry, 0 for x. So we'd have 0 plus 5, which would be 5. We square that, 25, make it a negative, and then add 2. So our y-intercept is negative 23. You can also just find this on your calculator as well on the table. Our axis of symmetry, this one's easy. X equals negative 5. Okay, that's our h value. Well, since we have a plus 5, that's the same as saying minus negative 5. All right, so you'll always flip-flop that h value. And our vertex is at negative 5, 2. All right, so graphing this. Okay, and here we can just go ahead and count by ones. Okay, and this is kind of what approximately our graph is going to look like. Okay, and it's going to go down all the way down and intersect with that y-axis at negative 23. All right. So biggest things here is vertex form is awesome because it gives us our axis of symmetry and vertex immediately. Standard form, it gives us our y-intercept immediately. Okay, and we have to do a little bit more math on our standard form. But I just wanted to go over our quadratic graphing.